Hello and welcome back to Swecodes. Welcome to the problem explanation of the Leetcode problem number 1605. Find valid matrix given row and column sums. In this tutorial, we'll explore an intriguing matrix problem and walk you through an efficient solution. Let's start with the problem statement. We're given two arrays, row sum and col sum, containing non-negative integers. Our task is to construct a matrix where row sum of I represents the sum of elements in the ith row, and col sum of j represents the sum of elements in the jth column. The challenge is to find any valid matrix that satisfies these conditions. Before we dive into the solution, let's review some constraints. The matrix can be up to 500 by 500 in size, with some values between 0 and 100 million. Importantly, the total sum of all row sums must equal the total sum of all column sums, ensuring a valid solution exists. Let's look at our first example. Given row sum 3, 8, and col sum 4, 7. One possible solution is the matrix 3, 0, 1, 7. Notice how each row and column sum matches our input arrays. There could be other valid solutions too, like 1, 2, 3, 5. Here's a slightly more complex example. With row sum 5, 7, 10 and col sum 8, 6, 8, we can construct the matrix 0, 5, 0, 6, 1, 0, 2, 0, 8. Again, you can verify that all row and column sums match our input. Now, let's consider how we might approach this problem. Initially, we could start with an empty matrix and try to fill it greedily, ensuring we maintain the required sums. We'd need to keep track of remaining sums and iterate until all cells are filled. However, there's an even more elegant solution. We can initialize our matrix with zeros, then iterate through each cell. For each cell, we'll set its value to the minimum of the current row sum and column sum, then update these sums accordingly. This simple approach guarantees a valid solution. Let's walk through the Java implementation. We start by initializing our matrix. Then we use nested loops to iterate through each cell. For each cell, we set its value to the minimum of the current row and column sum. After setting the cell value, we subtract it from both the row and column sums. This process continues until we've filled the entire matrix. Let's analyze the complexity of our solution. The time complexity is O, m times n, where m and n are the dimensions of our matrix, as we iterate through each cell once. The space complexity is also O m times n, to store our result matrix. The algorithm works by greedily assigning the maximum possible value to each cell without exceeding the row or column sum requirements. By always choosing the minimum of the remaining row and column sum, we ensure that we never assign a value that's too large for either constraint. This approach guarantees that we'll use up all the required sums by the end of the process, resulting in a valid solution. The solution is efficient because it fills the matrix in a single pass, without any backtracking or complex calculations. The algorithm is deterministic, meaning it will always produce the same output for a given input, but note that there may be other valid solutions for the same input. And there you have it. We've solved the valid matrix given row and column sums problem. This elegant solution demonstrates how a seemingly complex problem can often be solved with a straightforward approach. Thanks for watching, and happy coding!